So here's what I want to show you. You take your calculator, and if you, so we had those original derivatives, right? So if you go ahead and for y1, you can plug in the first one, square root of x plus 2 over e to the x. And then for the second one, that was sine squared, right? Okay. Because what I notice is that sometimes you have to like repeatedly type these things in, and it's obnoxious, right? To like type it over and over, and the parentheses get frustrating, and sometimes you can't see everything on the screen all at once, and you just feel like you could have a typo and you don't know. So if you type them in like this, go ahead and hit second quit to get out. Then it's kind of nice because you can type in using those now, okay, using your vars key. So for instance, if you wanted to do part A and they're saying like take dx dt and evaluate it at 2, then if you hit vars, you go over to y vars. Sorry, let me do that again slower. Go over to y vars, press enter because it's a function, and then y1 is that first function, so you can do y1 of 2. And it will just spit out the answer. All right? And then if you want to do dy dt, or sorry, dy dx, you can say alpha y equals, and you could say vars, go over to y vars, y2 of 2 divided by the first one of 2. It just makes it so you don't have to repeatedly type it in. You can type it in one time, know that your parentheses are in all the right places, and then you can use that for everything else. So there's how we get that slope right there. If you want to do, for part B, we're finding just the x-coordinate, so you could do 1 plus math 9 from 2 to 4 of vars, the first one. So you can literally do everything, like using these instead of typing it. I don't know if you're excited about that. I kind of knew that you could type it stuff in with vars. I'd showed that. I think I showed it to you guys maybe at one point, but I didn't like keep doing it. And then today I was like, there's got to be a better way than typing all these parentheses and stuff repeatedly. So you really can use it for everything, okay? So if you're doing it to type in the speed, I put a parentheses, and now I'm going to do vars y1 of 4 squared plus vars y2 of 4 squared. I think it just makes it easier to type in without risking typos. So if you want to do that, obviously you're welcome, but it literally works with everything. That's what I realized. Like you can take the derivative that way, you can take the integral that way, you can evaluate it, you can do all that stuff, and it just kind of is a shorthand that makes your life a little bit easier. Okay, so how did we feel about this question? Pretty good? Yeah, so I think as long as you have like the speed formula memorized and the total distance formula memorized, I think those were the hardest parts, is just whether or not you forgot those formulas. So I'm not going to talk a lot about that one. I figure I'll just give the rubrics out and we can look at the grading of it. Okay. So part A is not bad, just finding that area. And there's lots of different ways you could get the right answer. So go ahead and check, make sure you got 10.370. I did top half, so I said from 0 to 2/3 of the circle, and then from 2/3 to pi of the part that's not a circle. So I was looking at this part was the circle, and then that little part right there is not the circle, and then I doubled the whole thing. That's what I did to find the area. Lots of different ways to get that point, though, just based on or different points, I guess. And then don't look at my red because you'll see the rubric will make more sense. So for part B, I was remembering that dr d theta means dr dt over d theta dt. I don't know that it matters for that one though. Does it matter? No, you just find the derivative. So dr d theta at pi thirds is negative 1.732. This means that the rate of change of the radius is decreasing. So the radius is decreasing, which means that the particle will be moving towards the origin. Right, smaller radius. And then part C, this one says you're finding dy d theta. So first you have to find y, which would be r times sine. And then dy d theta evaluated at pi thirds would be 0.5. It's positive, so the particle's moving up. See how doable that question is without the typos? It's crazy. Much more sense. Yes, so the typo, and it wasn't a very big typo, I had dr dt equals d theta dt. Very minor typo, but meaning-wise makes the problem undoable and not make sense at all. Yeah. And then I think down here I did the same thing.
Yeah, but I think it ended up saying like d theta dt equals dy dt.
Yeah.
So I just said my answer from the first one was the same thing because they equal.
Yeah. Yeah, it ended, yeah, the question, but if you really think about it, it didn't make sense because of the t's and the thetas. It was like, this question is not going anywhere. Yeah, that was my bad. Okay, let me give you the rubric. Grant it. Okay, so part A is pretty straightforward, just finding the area. So as long as you remember the area formula, you're good. You've got 1/2 r squared, so 4.382. For B, you have x equals r times cos theta. It needs to equal -2, so what I did is I graphed this is y1 and this is y2, and then I found the intersection in my calculator was at 2.786. Okay. I plugged it into my calculator, and so I counted this as y1 and this is y2 on my graphing screen, and then I just found the intersection. And that's how I found my theta. A certain what? So for the window, whenever I set the window for these, I just think about the graph that they gave me. So the graph they gave me had a theta value from 0 to pi. So for my x min, I did 0. For my x max, I did theta. And then I know that I want it to intersect at -2. So I made my y max and min -3 and +3. And then that was exactly the right screen, so I could see everything. Part C, if the r is decreasing, then the distance between the curve and the origin is also decreasing. So the curve is getting closer to the origin. For D, to be able to find the point that has the maximum distance, you're essentially looking for a maximum, right? Like a relative max. And so you need dr d theta to equal 0. You can graph it on your calculator and find the intersection. That would be fine to solve for that, because since this is calculator active, it doesn't matter if your answers are exact or not. I didn't feel like getting my calculator out at first, and so I just went ahead and did it by hand. So that value there is pi thirds, which the decimal version of that should be fine. And then I plugged in the point just to make sure that this really was a maximum value, and it was, switches from positive to negative. So I said that pi thirds corresponds with the point that has the greatest distance because dr d theta switches from positive to negative there. But when we look at the rubric, you'll see they didn't include all that. They said it has to be that one because that's the only one where the dr d theta equals 0. Right? So this idea, since it says greatest distance, or it's the furthest away, they're still talking about a maximum value. So what we know about maximums still works, which is why we were able to use the derivative to figure that out. Okay, let me give you